My name is Arvind, Arvind Chigurala. I work as the Vice President of Engineer at Xero. We help law enforcement, like criminal cases, things like that, right? We have been using AI for a while now, right? But with all the latest advents, one thing I wanted to share with you, right, which I'm proud of the work that I'm doing, right? A lot of these law enforcement cases are about images, right? Images, videos, and trying to find the criminal within using those evidences, right? We recently developed something in the AI, right, where you can go and ask AI, right? I want every picture that has a dog in it, right? And so it's taking the text that you have put in, and it is trying to find all the images that have dog, right, and bring them back to the investigator so that he can look at those pictures, right? So that is where we are, right? So one of the primary things that I'm doing is we are making the transition so that we can help the law enforcement or taxing authorities or corporations, what you name. We are trying to help those. So today we are going to talk about primarily MCP, right? Model Context Protocol, what that is, how to use it, how does it fit into agentic workflow. That's what we are going to talk about, right? But before that, a little bit of context, right? Why do we need this, right? Why do we need MCP? So the primary reason there is today in the keynote, right? We learned that these LLMs are big, right? They have a lot of knowledge in them, right? A tremendous amount of training goes into it, right? And it is very hard to train those models, right? Lot of money, lot of time, lot of resources, all of that. So that's one of the drawbacks for the LLMs, right? They do a pretty good job, but that's a big drawback, right? And the ChatGPT 5, right, which is the latest, greatest of what OpenAI has, right? Its knowledge is only limited up to October 2024, right? So if you ask it anything, right, the base core model of it, if you ask it anything, it wouldn't know what that context or what that topic is, right? The OpenAI itself is building some more on top of it to give you the results. We will see what they are using, right? But the core model itself does not have more knowledge, right? So it's always behind. It's always running behind the time, right? And the model itself, right, it is very simple, right? It says predict the next word that is going to come. All that is doing is it's saying what is my next word, what is my next word, what is my next word. That's all it is doing. Model does not have a lot of intelligence, or it cannot do any actions by itself. All it is trying to do is generating the next text, right? Now we will look at 3 different techniques that are available to us, right? There might be few more, right? So this is rapidly evolving. There might be few more others, but there are 3 techniques that I want to cover today in how we come across these 3 things, right? The first one is RAG, right? What RAG is, right? You can always go to ChatGPT or Gemini or whatever. You can give it a PDF, right? As long as it can handle that content, right? 1 MB, 2 MB, 10 MB, I don't know, whatever they can take. You can give it that document and ask it to analyze that document, right? And it will work fine, and it will give you all the data that you want, right? Summarize it or do more analysis on it, or whatever you need to do, it can do it, right? So what we end up doing is, right, in enterprises we have gigabits of data. A lot of content gets generated, right? But we still want to use the LLM, right? So what we end up doing is we take all of our content, right, create what is called as an embedding, right? We create a number representation of our content. All the content that we have, we create a numbering system for it, right? And why that is important is we are trying to create a subset of data that we can take and give it to the LLM, right? We want to take, okay, I said, who is this guy, or something I'm searching for, right? So you want to take relevant data, right? You don't want to give all 15 GB because LLM will not be able to process. It's too costly, right? You cannot give all the data. You have to give it a subset of data. The RAG is really that. RAG is you're trying to take your huge database you have, a lot of data, a lot of content you have, find the subset of data that is interesting for a given user's query and submit that to LLM, right? Now LLM can do its magic, create a good report, add more analysis on top of it, you name it, right? LLM has all those benefits. It's going to do on top of that limited set of data. So RAG is really trying to take a lot of data that you have, compress that so that it is for that user query that he has given, and give it to LLM so that it gives you back the report. That's all RAG is, right? It is, there are a lot of tools out there that you could use to do RAG, right? Some frameworks, Llama Index or few other frameworks that are available that make it easy. How do you generate the embeddings, or how do you generate chunks, how do you generate vector databases? All of that is already built in, so it makes it easy, right? Those frameworks are making it easy to do all of that work, right? But essentially that's all you are doing. So that is about RAG. The next one we are talking about the agentic AI, right? I want to draw here, right, this diagram here. Before MCP, right, all of your data, whether it is in Google Drive or whether it is in OneDrive or whatever, they all directly talked to the server or to the LLM here, right? After MCP, they made a unified interface so that LLM always uses that unified interface to talk to your server, and those servers are in turn talking to different data sources, right? So you are building these servers here. Here these are different servers that you build, but the server connection to the LLM is constant. MCP is that, right? Model Context Protocol is a consolidated, a clear, simplified way where LLM is able to talk to the server that you built. That server can talk to whichever data set that's present out there, right? That's all the Model Context Protocol is, right? Once you go in and start trying to read about MCP, the nomenclature gets really little bit tricky, right? What is what they are talking about? So essentially when you look at the Model Context Protocol, you have what is called as a client, an IDE, right? Like it's cloud, or you could take Google Gemini, or you can take Visual Studio Code, right? You have what is called as a host here, right? This is the host here, one of those, right? And within the host, there is what is called as a client, MCP client, right? And that client talks to an MCP server. This is what you will write. MCP server is what you will write, right? That MCP server can talk to any data structure, right? It can talk to a database, it can talk to a file system, it can talk to name it, right? It can talk to all of that and return the data back to the LLM. So it's kind of this, right? RAG, you took a subset of data and sent it over to LLM, right? Even here you are doing the same, right? What you are doing is you are reading the data from various different places and sending it back to LLM according to the query that was sent by the user, right? User input some query. For that query, the MCP server is going to look at your backend databases, your enterprise databases, right? And it is going to return the data back to the LLM, and the LLM will format it, it will add its own analysis to it and present the data out. So that's what MCP is, right? So it's not only about retrieving the data. MCP is not about retrieving data. You can actually do some, okay, let's book a ticket, right? MCP says, this is the, LLM could come back and say, this is the ticket that I found, which is very cheap, so let's go do the booking. So you can write an MCP server that's actually calling a web API, which is booking a ticket for on behalf of the end user. So that is possible, right? It's not just about data anymore. You could literally write a function that's changing the state of some, and it's doing the real financial transaction or whatever you name it, right? So it's both data as well as being able to do some action is where MCP comes in. So we'll get into a quick demo here. So this is cloud desktop, right? File. settings, developer. I'm just showing how do you develop your MCP, right? If you wanted to develop an MCP server, this is how you are going to do it, right? You come here, you hit the edit config. There is this cloud desktop JSON file. Open that. That's all it is, right? The MCP server, we give it a name, right? We are giving it a Python script, yeah? Okay. So all we are doing here is a simple Python script, and we are telling where the Python executable is, right? That's all we are telling, where the Python executable is and what script you want it to run, right? And I'll show you the Python code here. You are able to see it? Okay. So we have this utility called FastMCP, or a library. This is, you could just ask any code generation platform, it will generate for you. The important thing here is there is an attribute, or there is a nomenclature that you put, right? mcp.tool. Once you say that, right, this method can be called by the LLM. Based on the user query, LLM can call into this API, right? So you are giving the specification, okay, this is the function that I want it to call, right? Internally it is using JSON, right? When it is calling into our Python code, it uses JSON over RPC to call it, which is a generic, right? Whether you write it in C#, whether you write it in Python, Java, you name it, they are all using JSON over RPC, but within Python, that's how you register your function, right? You are just putting this nomenclature here. These are all the functions that LLM can call into, right? There is a tool, there is a resource, and there is a prompt, right? You can even send out a prompt. So that is the prompt that LLM is going to use when it calls itself. It is going to use that prompt to talk. So let's see. So this MCP is straightforward, right? All it is doing is given hello world, right? Given the word hello world, it is converting into various different languages, right? We'll go here. New conversation. Translate. Sorry. So I'll show you where you can actually see what it is calling and how that works, right? Hello world in French is here. See, the good thing is, we'll go here. I have added this additional semicolons or whatever, right? The LLM actually figures out that's not the part of the translation. It actually strips it out, right? Strips out those additional characters and only gives you the real translation. So the point being, right, you have your API, you get the data from your API, the LLM is going to add a lot of value to that API by looking at its content, by formatting it, or by getting additional data from various different sources and putting it all together in a format that the user can use it, right? So that's what the LLM is. If we go here, go to folder, logs, cloud, mcp.log. So you can exactly see what the LLM is doing, right? As LLM is making calls, it's actually logging everything out here, right? So it's telling it is looking up that. Let me see if I can. Go up a little bit. So right there it is using the MCP server, right? It started the server, it's contacting our MCP server. We didn't have to do a lot, right? All it was a Python script with few attributes that I had to add on top of it. And within those functions, you could do whatever, right? You could talk to any service, anything, and then retrieve the data back out. I'll just show 1 minute here. So one important thing here is the LLM is dependent on your comments here, the comments that you put here. It is dependent on that to figure out what that API is doing. Right? So it looks at this comment and it says, okay, this is going to translate hello world into a different language. So it knows, that's how it knows what this API is supposed to do. So the comments are pretty important for LLM to understand your function, right? Like you see, there is not a lot to the function, right? It is literally just going in from a dictionary, it is pulling out the corresponding word and sending it back out, right? Instead of that, you could have called in an API and retrieve the data back out. With that, let's go back into the presentation. So we'll talk about some best practices or security issues within the MCP architectures, right? This is so much easy, right? Given how easy for an LLM to call into an MCP server, right? If you are connected to a server, if you are connected to an MCP server that you don't trust, right? Or which can take your data out and use it for malicious purposes, it's so much easier, right? Because LLM will call with all the data that it already has so that the MCP server can make the appropriate decision and send the data back out. So that is a big security risk, right? So when you are adding, right, in the screen where you added the MCP servers, you have to be careful that you are only adding the servers that are really, you know them, you trust them, right? That is important. And if you are, one of the things, right, these MCP servers are only useful when they are talking to other APIs or other things, right? So when you are talking to these APIs, you need some API key, some session key, or some kind of authentication and authorization, right? And you got to be careful with those, right? You need to make sure that they are recycled, they are encrypted, things like that, so that no one is able to get into your credentials and APIs and all that, right? And what you expose, what are you exposing within your MCP server should be very measured. You don't want to expose whole world, right? You want to expose only limited set of APIs that you are really wanting to target, right? So that you reduce the general common sense principle, right? It is this, you are trying to reduce the surface area. And the other thing is you want to make sure you are logging, right? You are monitoring, you are tracing the API calls. So you understand the usage pattern, you understand any malicious behavior, right? I might go as far as saying that once the data is written from your MCP server, you might want to validate the data being sent out and make sure that you are not returning the data that's not supposed to come out of MCP. Because they can literally prompt anything, right? The user could go in and prompt whatever he wants to, and in that response, the API could return any data that you are not supposed to, right? So you want to check the prompt as well as you want to check the data that's coming out of your APIs, right? That is the best practices. It's really simple, right? Once you get a hang of it, it is simple, but after that is where you need to spend all of your time making sure you put in proper checks and balances in place. And the last one is the small language model, right? or we can even call it as model tuning. You can take a bigger model, right, and tune it, or you can take a small model like Microsoft Phi or Google Gamma, right. It's a very small model. It only has like 30 billion parameters, 30 billion knobs that you can go with, and you can add additional data to it, right. So it has the base knowledge of the English language or whatever, right, but then you are adding more to it, right. You are adding your enterprise data or enterprise content to that model so that you can use that model, right. That is the third way of doing dealing with large language models, because they have some inherent fallacies. And I think that's all. Thank you.